Good evening, students. I'll start with the class. So in the previous class, we had solved problems based on, we had seen how to find difference between, one was instant speed and the other one was instant velocity, and the other one was average. So this was what always indicated by ds upon dt, and in this we have to differentiate or find the derivative. Over here, this is indicated by delta s upon delta t. Always final minus initial upon time final minus time initial. Here we don't wait a minute. Here we don't have to differentiate or find the derivative. So these are the two different ways to find. You have to be careful. This is exactly at that point and this is over a time period. Now same like that only we'll have some problems based on acceleration. Okay, so next topic will be acceleration. So what it is nothing but rate of change of velocity as per the definition. So how we have velocity is what? Nothing but change in displacement per unit time. Same way, what will be acceleration? It is nothing but change in velocity. Now, same like how we had for velocity, we will have instant acceleration and we'll have average acceleration. Now velocity is what? When your distance is changing. Acceleration is like one step ahead. Acceleration is when your velocity is changing. Try to understand. This is means like velocity is like a speed when you're going from A to B. If you are going throughout, like the distance, how much you are covering and how much time will give you the speed. And acceleration means, suppose if you are going at 20 kilometers per hour, then suddenly you are going at 40 kilometers per hour, then you are again reducing your velocity. So if you are changing the speed of your bike, so that is always called as the acceleration. And here it means what? You are changing your distance with time. Okay, and here you are changing your speed with time, that is acceleration. So same way here, how it will be, instant acceleration will be using the letter dv. Now what was velocity? Instant, ds upon dt, and this was delta s upon dt. This s means displacement, this was distance. Now for acceleration, what will come? V will come, because your velocity is changing with respect to time. So this is the formula for instant acceleration. and this one will be for average. So in terms of time, this it will be what? V final minus V initial upon V final minus V initial. Unit of acceleration is always meter per second square. For velocity, it is meter per second. And for acceleration, it is meter per second square. Any doubts in this part between the difference in formulae? This is instant, this is average. This is all what you need to know, and the unit. That's it. Now we'll just see, suppose in terms of slope, how it would be. The graph. This was for, suppose if you plot for displacement versus time, and if you get something, if anything is changing with distance per unit time, then that is definitely velocity. We just saw that in the previous class. Now what will be slope of time versus velocity? This is slope of, this already given to you, time versus displacement, or also called as position, I told you. This is called as velocity, and this will be called as acceleration. When velocity is changing with time, your distance is changing with time, so that's why this is velocity. Now, anyway, doesn't matter. This is just an example. So this will be velocity if you plot here, if you put time here, and if you are getting a graph like this graph is always called as the acceleration. X-axis is always fixed. Both the places it is time. But if you are plotting it with respect to distance, then it is velocity. If you are plotting it with respect to velocity, then it is acceleration. Definitely, acceleration is also vector quantity. Why? It will have both magnitude as well as direction. One note. Slope means what? Like you can see, what is slope? If you are riding a bike also, how do you understand something is increasing or something is decreasing is called as a slope. So note, as the slope increases, definitely you know that on a slope, if you keep your constant speed of the bike, it will start coming back down. So on a slope, you have to always accelerate. So as the slope increases, acceleration also increases. I'll show you how it is, how it looks. Just see. If I want to check over here, suppose, okay, at this point, I just draw a tangent, and it will always make some angle theta with your x-axis. Here you have a different angle at this point. Now for the same graph, I'll check my acceleration at some other point. This is velocity versus time. I want to check here. Now I'll draw tangent at that point. So definitely you saw that your angle has increased. Okay, so your angle has increased means this angle which has increased means definitely your acceleration also increased. So as the slope increases, the acceleration also increases. So this is a steep angle C. So definitely your acceleration has increased. So this is what it means. So as the slope increases, acceleration also increases. Suppose if it's constant, just see here, the angle is also changing, no? Here you see. At any point you go to check. At this point, if I try to draw a tangent, everywhere theta will remain same. So in this case, what you can say, acceleration is constant. Here, acceleration is changing as theta changes. Here, acceleration is constant as theta is same. This will not be asked for exam to plot and show, and this is only for your reference to understand. Main thing in this chapter is only problems. Let's start with the problems. Hope you all remember the derivatives, how to differentiate. The main formula quickly, if S is t raised to n, ds upon dt is always n t raised to n minus 1. This is the formula which we'll be using. Then we know that straight away certain things I told you to directly remember. Derivative of any pure constant is 0. And derivative of t is always 1. Derivative of t square is always 2t. Or you can remember by this formula. But these two directly you remember, derivative of constant is 1 and derivative of t is 1. Now question is, velocity is given to you. Find acceleration also find average acceleration from t equals to 0 to t equals to 3 seconds. Now exactly at some particular second I told you is always called as your instant acceleration at that particular point. and average means from the initial to the final point. So even if they don't mention instant acceleration, you have to understand only when they give you one particular single point of time. The first part will find instant acceleration. So what is the formula for instant acceleration now? A is nothing but dv by dt. Remember the difference, huh? V is ds upon dt. A is dv by dt. Velocity you have to differentiate. So here if the letter S was there, we use ds upon dt. Now if the letter V is there, which formula will come? Definitely you cannot write ds by dt here because this is not S. So this will be only difference here will be V. But rest, whatever answers you get on the right hand side will remain the same, whatever I had given in the table. Only the letter V will change. If this is V, this will be V. If this is S, this will be S. If any other letter is also there, the only letter will change, but the formula part, what you apply, that will always remain same. Only the letter changes. So derivative part always remains the same. So let us find the instant velocity. So what is velocity given to you as 2t square minus 4t. So we will find a derivative now of this equation. So I told you if there's a letter S was there, we have to use S, ds by dt. But now this is V. So which letter will come? dv upon dt. This is a fixed term for V. This side. Can anyone tell me what is the answer here? What is derivative of t square? What is the derivative of t square? First, quickly. 2t. Yes, that will be 2t. Middle sign is minus. Coefficient keep at the side only. And then derivative of t is 1. So whatever you differentiated, that is always your acceleration. So acceleration will be 4t minus 4. And now at which time has been asked? At t equals to 3. So A what you got? 4t minus 4. So at t equals to 3 means put value of t as 3. Wherever there is t, you have to just put that value. This will be 12 minus 4. So A is 8. Don't forget to write the unit, meter per second square. So this is your instant acceleration. Anyone having doubts, have not understood, want me to repeat again, you can ask. So once you find the instant, then go for the average. Average will not be the same formula. Average will be the other one, delta V upon delta T. This is average one I'm finding, the second part. So this is the formula. V final minus V initial upon T final minus T initial. So what is it? V, which from where to here? 3 seconds. And then starting is 0 seconds. Time directly can put 3 minus 0. Final time is 3 seconds, initial time is 0. Now we need to find what is the value of V3. So take the V from your question. Find V3. V3 means at t equals to 3. So wherever there is t, put 3. And then calculate your answer. So that will be 2 into 9, 18 minus 12, 6 meters per second. Velocity means meter per second. Then V0 will be, just put, this was at t equals to 3. This will be at t equals to 0. Anyways, this also will be 0. So put the value here, 6 minus 0 upon 3 minus 0. The answer is 2 meter per second square. Write a unit for acceleration. Any doubts in this problem, you can ask. Next question. Now be careful, huh? You see what all data has been given to you. Now S has been given. And acceleration when body is at rest. Also find displacement when body is at rest. Okay, now see. Now velocity is not directly given to you. In order to find acceleration, what do we need? We always need velocity first. Why? Because acceleration is nothing but change in velocity upon time. If you look in the question, your velocity is not at all given to you. What has been given? The letter S has been given. S means is not velocity. It means displacement has been given to you. This is displacement. Okay. So first what we'll have to do in order to find acceleration, first we'll have to find velocity. So whenever body is at rest means when velocity is 0. So before that, we'll first find velocity. So given any distance, now you can always find velocity. What is the formula? V is always ds upon dt. This you already know. What is velocity? Change in distance upon time. So differentiate this. Ds upon dt we got. So what is derivative of t cube? Use the formula. T raised to n is n, t raised to n minus 1. This will be 3 t raised to 3 minus 1. Or directly you can write square, no problem. This is the coefficient and derivative of t square is 2t. So from distance, first I'll find velocity and then after that I'll find acceleration. Directly from distance, we can never find acceleration. There will be two steps. First find velocity, then find acceleration. If velocity was given, then directly next would have been acceleration like the previous problem. So please look at the question carefully what they have given. Simply don't assume this as v and then do. This is your velocity which we got after finding the derivative of the distance. Now what has been told? Body is at rest. Body is at rest means I told you always v will be equals to 0. This is a fixed condition. So v equals to 0 means put v as 0. And now we have to solve this equation. You can write it ulta also. 3t square minus 12t is equals to 0. 0 you can write this side also, no problem. And now take out whatever is common between the two letters, two terms. So 3t is common. So what we'll get either 3t equals to 0 or t minus 4 equals to 0. So t is 0 or t equals to 4. So you have two options. So the body was at rest at two things, at t equals to 0 and t equals to 4. So this is the time which we got. Now we have to find acceleration. Acceleration at which point? One at t equals to 0 and one at t equals to 4. So these were the two places, two times when body was at rest. Now we'll calculate acceleration. We are finding acceleration now. So what is acceleration? dv by dt. Now definitely I know what is v. We just now found out. 3t square minus 12t, I know. So what I'll do, I'll find the derivative of v. dv by dt is nothing but we have to find derivative of v. Now I know velocity was not given to me in the question, but I found out after finding derivative of the distance. Now we'll again find a derivative to get the acceleration. So remember, velocity is given, then directly acceleration is dv by dt. But if distance is given, there will be two steps. First we have to find ds by dt and then dv by dt. So two steps here. If question is given to you in terms of s, and if it's given directly in terms of v, just one step, only one time derivative, otherwise two times. So now dv by dt. The word v will come here because this is v. Now find a derivative. 3 is outside, derivative of t square will be 2t and derivative of t will be 1. So what you got acceleration as 6t minus 12. Now at which 2 points it was at rest? at t equals to 0 and t equals to 4. So acceleration we have to find at 2 points. So first we'll find at t equals to 0. The acceleration will be minus 12 meter per second square. Wherever there is t, put 0. Then next is which point? T equals to 4. Same equation, but now instead of t, it will be 4. So plus 12. This is the acceleration when the body is at rest. Whether at t equals to 0 or at t equals to 4. Any doubts in finding the acceleration? Then ask. Now one more last part has been asked in the question. Also find displacement. Displacement means S when body is at rest. So which other times again body is at rest is t equals to 0 and we got t equals to 4. What was the equation given? Where is S given? Already there in the question. S is given to you as 3 cube minus 6t square. In the question it's there. Whenever you ask to find displacement, look out for this equation in terms of S. Now at t equals to 0 means wherever there is t, put 0. This is 0 meters. Displacement will always be pure meters. No square, nothing. And at t equals to 4, sorry, I got a call. In spite of even if I decline it again and again, still some students call. They know I take a class at this time. Okay, so calculate this 4 cube. How much I'll get? 4 cube is
64.
yes. Don't write it as 12. Students, please be careful with this. You all may think I'm what simple thing I'm telling. I'll send you all later also the screenshots if some students are doing that mistake. They really do that. They just write 4 cube as 12 and keep while answering. Okay.
96.
Negative you are getting, so don't worry. Even displacement you can always get in terms of negative answer. It only means that it is going in the opposite direction because displacement indicates both. What is that? It's a quantity. It indicates a value as well as direction. So it's like the person has gone and come back, then gone further. So this was your initial and this was your final. So it's like it's gone ulta. That's why you might get negative. Okay. So this will be 96, 64. Okay. How much alcohol you said? This will be meters. This will be 2 minus 32.
Minus 32.
So if you want, you can write modulus also. Just check if your teachers are asking you to write positive only, then you can just put modulus sign and make it positive, and otherwise you can leave it this. Displacement is 32 meters. So that will be your answer. Then next question.
You have 3 marks for this question.
Huh?
3 marks for this question.
Yes, everyone will, some keep only half mark. It depends on your teacher. So there are no fixed marks actually. Like half mark here, half mark there, then they will distribute. So don't study in terms of marks, study directly in terms of understanding. Because some teachers, they just give for half mark some question. Then same thing some teachers give for 1 mark. Up to them. I'll anyways send you all college wise now. I'll send you all the question papers of previous years for this. So later you'll understand how your teachers are giving as per the college. So once I finish with all the 3 chapters, I'll do a quick revision based on your question papers. So you'll have an idea how the questions come in the exam. Next, just to tell you the direction of the motion. So direction of motion, suppose if you have normal, your x-axis and your y-axis. And with reference to this side is always your negative x-axis. So this would be our origin. Suppose if our object is moving this side, okay, on the positive x-axis side, object moving in positive direction of x-axis, and velocity is always greater than 0. It means velocity is always positive. The object is moving in the positive direction of x-axis, answer will always get as positive. Same way, if anyone is moving, so this side velocity is positive. If it's moving towards negative direction, opposite direction, then velocity is always negative.
Voice is too low.
Too low? Okay, wait. I'll hold the mic then closer. Now you can hear?
Yes, teacher.
Okay.
Yes, teacher.
So if the object is moving in negative direction of x-axis, then velocity will always get less than 0, which means it is negative. So example, suppose if you have answer, if you are getting plus 5 meters per second velocity. So what, how you know the person or the object is moving? Positive direction of x-axis. With a speed of 5 meters per second. How do you read it as? Whenever you get velocity as 5 meters per second, So whatever the object or the person, and not necessary this thing has to start from the this one, yeah, from the origin. The person could start from this side also, from the negative infinity side also, but still if he's moving this side, still it will be positive. If the person is starting here, still if he's coming this side, it will be, this is positive and this would be negative. So not no, only with reference to origin, it could be from any point. So if he's starting from here and going this side, and if he's going this side, it is negative. So how do we read? If velocity is positive, the object is moving in the positive direction of x-axis with a speed of 5 meters. Here if it is negative, so same thing, in negative direction of x-axis, here it is important, just see, with a speed of, you while reading you always write like this. Already you mentioned the direction, again you don't have to put minus sign. Already you are telling he's moving in the negative direction. So by default, you know that velocity is negative, but you don't have to write saying again minus into minus will make it plus again. So already I mentioned the object is moving in the negative direction of the x-axis with the speed of, so speed means you are just telling you are just telling the value of the speed. You're not telling the direction. Direction you have already specified here. So don't write again negative. So while reading, it is understood that way. So a person is moving in the negative direction with a speed of 5. We don't say with a speed of minus 5. So the question was, find velocity at t equals to 2 seconds, acceleration at t equals to 3 seconds. Also find.
Teacher, your voice is too low.
Okay, while writing, I normally tend to speak little slow. The question, okay, wait. Sometimes the mic goes down. So velocity at 2 t equals to 2 seconds. This is already seen on the board, so just write. Also find the time when body is at rest. So the distance is been given to you. Now you have to see. Now you have to find velocity, then you have to find acceleration. Can anyone tell me what will be the first step? I want to find velocity, what I have to do?
T is equal to 2.
What? What is that?
Teacher, we have to put T is equal to 2.
Directly. So what you'll get, t equals to 2.
No, we have to combine that 3t square minus, we have to do that.
So what in short we have to say, find a derivative.
Derivative.
Yeah. Or else you can directly say v is ds upon dt. So directly, directly if you put 2 seconds, what you are going to get is the distance. And they have not asked you to find displacement at 2 seconds. If they had said find displacement at t equals to 2 seconds, straight away put 2. Now velocity, this is not a formula for velocity. V has to come in. So definitely V is ds upon dt. So your first step is to find a derivative or differentiate, whichever word you find a derivative first. So that will be ds upon dt will be t cube will be 3t square, then this will be 2t, 9 into 1. So now you got v, that's a velocity. And now you can take it 2 seconds. Now put wherever there is t, put 2. So just confirm once that your answer you're getting is in terms of v. So this will be 12 minus 24, then plus 9. So minus 12 and then plus 9. So minus 3 will get meters per second. So if I want to write, how I will read it as, so the object is moving in the negative direction of x-axis. I want to just read it. Of x-axis at 3 meters per second. Don't put negative again. You can say with a velocity of 3 meters per second. Now we'll find acceleration. To find acceleration, what we need? V. So V you write again. So acceleration is dv by dt. So find derivative of velocity. We have to find the derivative of velocity. So this will be 3, then 2t. Derivative of t is 1. And derivative of 9. What will be the answer? What is derivative of 9? Yes, very good. 0. Why 0? Because it's a number, constant, is a single number. These all along with t, they are called coefficients. But a single number is a constant. So derivative will be 0.
Yes, that should be 12, no? 3t square minus 12t, no?
Okay. And then at t equals to 3 you put. Now acceleration at t equals to 3. So check for the time at the right thing. Don't get mixed up with this. So t equals to 3. So A will be 6 into 3 minus 12. Now check for the unit. Meter per second square. Current went, so it will be little dull. And last step, what to do? Can anyone tell me? When the body is at rest, what is the condition we have to use? Find a time when body is at rest.
Velocity is equal to 0.
Yes. So put velocity equals to 0. And then put 0 here. We have to solve this equation. body is at rest. So V is equals to 0. So what was V? 3t square was a V. So that is 0. If anything is common, take out common first. So here 3 is common. So remove 3 common. Whether I write V this side or this side doesn't matter. So 3 will go that side. 0 upon 3 will anyways give you 0 only. No need to write also that, directly can write it as 0. But then students after some time now while studying back, they'll wonder where did that 3 go. So that's why I've written like this. And now how to solve a quadratic equation is by finding the factors. Factorize the equation. So which are the factors you are getting?
3 and 1.
Yes. Minus 3 and this will be minus 1. Because both has to give me minus 4. So directly you can write like this, shortcut. Or you can do the long method of splitting the middle term. But while writing, make sure you are using the right sign. Minus 3 means minus only will come here. If this was plus, that would be plus. And now we have to equate. So either t minus 3 equals to 0 or, and one more thing, time you will never get negative. If you're getting negative, you have to discard that answer because time can't go in negative. If both are getting negative, means something is gone wrong there. If one is positive, one is negative, one you have to cancel. So t is 1 or t is 3. That's it, was asked. Nothing else is asked. Only the time when the body is at rest. Suppose if you have like this type question, is t square plus 4. Find displacement in 3 seconds. Second, find displacement at 3rd second. So what is the difference between these two? Now, in 3 seconds means, suppose if you are starting from 0, then this will be 1. After 1 second, you must have traveled this much. Then 2, then you must have after 3rd second, you will reach somewhere. So from 0 to 3 is called as in 3 seconds. So in 3 seconds, from 0 to 3 seconds, how much distance have you covered? So that much you have to find. So first one, so we'll find in 3 seconds is from whole thing. So in 3 seconds, so that will be, you can just directly substitute. Three because anyways you are starting from 0. So that will be 9 plus 4, that will be 13. Now the second part at the third second. At third second means this much. This is only this much at third. After the 2 seconds, your third second starts. So within that much second, how much distance have you covered? So in that case, what it will be? This whole thing. So that would be what? S this minus your, otherwise your T3 minus this part you can minus. So whole thing minus this will give you this. Or you can say displacement only I will write, because anyways they asked you to calculate displacement, no? At the third second means how much distance you have covered in the all three and minus the second one. So this part you will get. So this will be at third second will be S3 minus S2. So first calculate what is S3. Put value of TS3. So definitely that you are getting is 9 plus 4, that is 13. Then calculate S2. So wherever there is T, put it as 2. So 4 plus 4, which is 8. So at third second will be, so 13 minus 8. That will be 5 meters. Both the way you can write meters. So at third second means then you have to check like that. So that's the difference in 3 seconds and at third second. Same it would have been if 4 seconds were given, in 4 seconds at fourth second. So these are simple questions based on if displacement is given, how to find velocity, and then from velocity how to find acceleration, and when body is at rest. So only the equation will change, but the steps will always remain the same. If you know how to find the derivative, any equation directly you can find the answer. Next, suppose this was all in terms of normal t it was given. Suppose if it's something given in terms of I and j, you will come across. So that I and j terms are something called as vectors. So briefly, I'll just explain to you what are vectors. Okay. So these are basics of vectors I'll cover up. Same how I done for derivatives now. A vector. No. You always have, suppose, x-axis, you have a y-axis, and you have a z-axis. This is three-dimensional, okay? Directly I'm explaining you in terms of three-dimensional. If it is two-dimensional, then it will be only x-axis and the y-axis. But whatever explanation will remain the same. So only thing z will be missing there for two-dimensional. Now consider any point, suppose if there is in space. Okay, any point P is there, it will always have some coordinates. How we have any point, no? 0, comma 2. So what are these? They are always called as the coordinates. So this is always as the x coordinate. This is always called as the y coordinate. Now in 3-dimensional, it will have all three. So suppose this is your x coordinate, y coordinate, and z coordinate. We can convert any point in terms of vector. Vector is nothing but the direction. Vector means it is some kind of direction. So along the x-axis, you are having some fixed vectors. Okay, these are called as fixed unit vectors. So the fixed standard, also called as standard So what is this I cap, j cap? Nothing but they are the vectors. I is always along the x-axis, y is always along the this, and this is always along the z-axis. So only this much you need to know. I means it's a vector along the x-axis. J is always along the y-axis, and k is fixed for z-axis. Any given point can be converted into a vector. How can I convert a point into vector? Is nothing but this. If this is P, no, you always put a bar on top of this. Bar means always a vector, or you use this symbol, arrow or simple bar like this. Any point can be converted into a vector by just putting a bar on top of it or an arrow on top of it. And for x, I have to just give it as I cap, y, I have to put a j cap, and z, I have to give k cap. So I have put a direction for them, for the x-axis, for the y-axis, and the z coordinate. And then I converted a point into a vector. So this is a fixed way. Any point can be converted into vector. So this is called as a vector. So this has what? Magnitude, also called as a value, as well as direction. This has both magnitude as well as direction. Now, given any vector, I don't want to know what is the direction of it. Suppose I just want to know what is the magnitude of it. There's a fixed formula to find magnitude of any vector. That you write and keep, that you will need for in the problem. Okay, so magnitude of vector, also called as a scalar or you can just say value of the vector. Value of the vector. You just have to put a magnitude like this, like a same like the modulus sign. It has a same like modulus sign you have to put. And I want to remove out the direction. So whenever I want to remove out the direction, this is a fixed formula, root of all the coefficients square. x square plus y square plus z square. This is a formula for magnitude of a vector. Keep this in your head. If z axis is not there, then only this much will be the answer, x square plus y square. Okay, and just write here and keep. These are called as the components. These three, no, x I cap, these are called as the components. So right now P is having three components, 1, 2, and 3. X component, Y component, Z component. Any doubts in this? Any point can be converted into a vector by putting a bar on that. This magnitude formula, any vectors, I want to know only its value and not the direction. I have to find this. Whenever a question is there, suppose as this 3t I cap plus 4t j cap. Now something in terms of I and j also you might get a problem. Till now we were solving purely in terms of t only. There was nothing called as I cap, j cap. Now that vector component is come up. Now how to solve this type problem? So what it is just trying to say is, now they are trying to indicate you the direction also. So basically, this is always your x-axis and this is your y-axis. Now there is no k term, so this will be only in terms of x and y. Now it's trying to tell you when the person is moving, his x component and the y component is also changing. Now don't try to think, oh, he's moving at the same time in this direction also and he's moving at the same time in y direction also, how that is possible. You must be wondering, he's going in the I direction also, x-axis also, and how his y direction also is changing. How both directions can be there. It is not exactly meaning that way. What exactly it means is, suppose if you have a normal graph, if the person is walking straight like this only, this is called as, suppose linear motion is going exactly in a straight line. If you notice what is changing here, 1, 2, 3, 4, the x, only the x component is changing. Is the y changing? Y is 0 everywhere. Y is constant, y is not changing. Then that is called as a linear motion. Only one component is changing. He is moving only in the x direction. Y is not changing. Now suppose if the person is moving somewhere slanting. Now he reached at this point. Now what has happened? Here x was 1, y was 1. Now after some time he reached here. Now what did it change? X also changed, y also changed. Now he reached here. Again, x also is changing, y also changing. So in this type, so x component as well as y component is changing. So basically, it's trying to say that the person is moving somewhere like this So x as well as y component is changing. So don't think he's running around this line first and then trying to run around y line. It doesn't mean that way. Just that when he's moving, both x axis, x coordinate as well as y coordinate is changing. No one will ask you to plot the graph. It is only to understand what does this mean, I and j. So I is nothing but along the x axis and y is along the y. J is along the y axis. That's it. Now this will be given. The question will come like this now. This is given to you. Find velocity at t equals to 1 second. Find speed at t equals to 1 second. Find acceleration at t equals to 2 seconds. Now your displacement is given in terms of vector. Just put a bar here. Even if it is not there, it's okay, understood, but it's a vector. The moment I and j is there in the question, it means it's a vector. Now this vector is having two components. So which are the two components? This is one is your x component, that is 3t. Only this part you have to write, okay? Which is the x component. This is like x I cap, no? That way. And which is a y component, that is a 40. Don't write a vector. I am just writing the components. What tells me which is y? The letter j tells me this is a y component. The letter I tells me it's a x component. So now this time I have to write separately as x and as y. So same way I'll have two velocity components now. So Vx will be equals to dsx upon dt and Vy will be normal formula, okay? If you're getting confused, what is V? V is nothing but ds upon dt. This definitely all know. Velocity is change in displacement upon time. Only difference here is we have to put x in x, your y and your y. Now differentiate this. What is the answer? So 3 into derivative of t is 1. This I found a derivative, so I got answer is 3. Same way find a derivative of this. Or directly you can find here 4 into 1 is nothing but 4. So we have to separately find a derivative for the x component and the y component. Anyone who has not understood, just given this, take separately, this is for x, this is for y, separately find a derivative and then you can add. So this will be v will be what? Total vx plus vy. Add both the components. So while adding, again we have to write in vector form. So just write I for this fellow and j for this fellow. You have to take it back and write it in v form. If your teachers are not using this bar, you can just ignore. So this is my velocity. Add both the components. You have to add back and write together. Why I and j? Because your question was also there in terms of I and j. Now, what is been asked? At t equals to 1 second. Is there any t here? No. There is no t. This is for your understanding. Don't write like this for exam. No t in velocity. No t term is there. So there's nothing to substitute. So v will remain that much only. Okay. That means it is constant. Whenever that the t term is missing, no, then it is called velocity is always constant. It will not change. See, v will remain same. There is no t only to substitute 1. So velocity is constant. So your first part is done. So velocity at 1 second is same, 3i plus 4j. Even if they had asked find velocity at t equals to 5 seconds, still answer would be same because there is no t to substitute. So therefore velocity at t equals to 1 is this. So your first part is done. Now second thing, speed has been asked. Now understand the difference. Velocity is a vector component, vector quantity. So it is there in terms of vector. Now speed I want to find. Speed is always a scalar quantity. Means what? No direction. No direction means what? Speed will be. I just now while teaching you that vector basis, I told you anytime you don't want the direction, you want only its value, then you can always find the magnitude. You can remove that I and j. Okay, remove the direction by finding the magnitude. So speed is nothing but magnitude of velocity. So write this in. So how to find the magnitude? So there will be no z term here because there is no k term. So speed is root of x square plus y square. Means what? The x component and the y component. So fine. So this will be 3 square. No putting I and j. You have to remove I and j because I don't want direction. I want only the magnitude. So 3 square plus 4 square. So 9 plus 16 root of 25. And root of 25 is nothing but 5. So speed is 5 meters per second. So that is only a value. So speed will come in terms of pure number and velocity will come in terms of vector like this with I and j, and speed will be this like this. Any doubts in this? Now still there is no t to be substituted over there. So that will anyways remain same. That will not change. Now the acceleration part. Now in order to find acceleration, I want what is Vx separately same way. And what is Vy. So what I have to find? Find Ax and Ay now, separate components. Acceleration of x component and acceleration of y component. In order to find Ax, what I need? What is Vx and what is Vy? So what did I get? Vx is, I got the answer as 3. And what did I get? Vy as answer as 4. So just write it back. And what is acceleration? dv by dt is the formula which you know already. Acceleration formula is what? dv upon dt. For this one also you write acceleration is nothing but velocity upon time. You have to find a derivative. Only difference what you put here, x. Here just put y. What will be the answer after finding the derivative? Can anyone tell me? Find derivative of vx and tell me what is the answer. What is derivative of 3?
0.
0.
Yes.
0.
Yes, answer will be 0. Here also answer will be 0. So acceleration overall will be 0. Any doubts in this? No. Okay. If you want, you can simply try this problem. Find velocity, speed, acceleration at t equals to 1 second. The only hint I'll give you is your your x component will be t square and your y component will be 3t minus 1. Whatever is the side of j is always a y component, and whatever is this. And from now then on, you can just wherever there is t, if you find somewhere, just put t as 1, then later while calculate. Just give a try. Otherwise, anyways, I'll solve it in the next class. If you have solved, then you can send, no problem. I'll stop here. Just take attendance.